Hello, my name is Rekka. I'm an illustrator working as half of Hundredrabbits, which operates on a sailboat. We rely on solar energy to power our workstations. We make art, books, and games using small tools we designed to make use of older hardware. Sailing to faraway places, we often come into situations where bandwidth is an issue. Visiting image-heavy websites is costly and sometimes impossible. Parkinson's law, when applied to the internet, states that whatever the bandwidth, applications will always evolve to consume more than is currently available. The size of the average web page has increased at least threefold in the last 10 years. This growth in data traffic means that more energy is required to transfer 1 megabyte of content over the internet, which in turn increases the need to manufacture more powerful computers. For visual artists, a website can be made lighter by optimizing its images for the web. It is an extra step that is worth taking because it ensures greater access for everyone. It reduces energy use, while prolonging the lifespan of existing computers and phones. In this video, I will cover techniques to optimize images for the web that have worked for me. There are many ways to do the same thing, so I will mainly focus on JPEG, the most widely used image compression standard and digital image format. It compresses images very efficiently, while minimizing the loss of quality and is available on older browsers. Here are two images. One is compressed for web, the other is not. Yet, they would probably look identical to an average visitor. To process individual images, I like to use GIMP. It's a free, open-source tool available for most operating systems. All of the options detailed next exist on most photo processing programs. If you like to use batch processing tools like ImageMagick, you'll encounter these same settings. The following steps are the equivalent of doing a save for web, but I will cover in detail what does what. Click File, Export As, check Show Preview in Image Window to see the final file size changing in real time. When you save a file in JPEG format, a dialog is displayed that allows you to set the quality level, which ranges from 0 to 100. The default quality of 85 usually produces excellent results, but in many cases it is possible to set the quality much lower without noticeably degrading the image. Generally, lowering the quality is enough for most people when compressing images, but I will cover the most useful elements in the advanced setting options because I think they're worth knowing about. When playing with quality levels, as soon as compression artifacts become clearly visible in a border area, you can improve the image quality while further reducing the file size by using the smoothing slider. Smoothing reduces image size by removing pixel information. It also helps to mask artifacts. Setting the smoothing at 0.10 to 0.15 reduces a good amount of image size without blurring the edges. Progressive doesn't affect the image visually, nor does it shrink its size. Its purpose only becomes evident when the file loads on the web. It is a set of hidden instructions that is embedded in the JPEG, readable by a web browser, telling it how to load the image. A JPEG without this setting checked in will load from the top to the bottom, and on a slow connection it may not load all the way. A progressive JPEG will load all of the image at once, quickly, at a low quality, and then will become more and more detailed progressively. If my connection is terrible, I'd rather have a general, meaningful idea of what the image is rather than having it show partially. Cameras embed another kind of hidden information, called metadata, into every image or photograph. Metadata keeps information on when the file was created, last edited, etc. There are different formats which can be used to store metadata in JPEG images. The JPEG format is designed to compress full-color images by exploiting known limitations of the human eye, notably the fact that small color changes are perceived less accurately than small changes in brightness. Another way to compress an image is to limit color information by way of subsampling. Subsampling refers to how often color data is sampled in an image. Lower sampling means fewer colors, and pixels stripped of their color information will instead share color from neighboring pixels. It is difficult for our eyes to discern this change because, as mentioned before, our eye is more sensitive to brightness than color. Brightness in an image is what carries all of the detail in a photo. The different ratios listed in the subsampling drop-down menu refer to how many pixels contain color information in a given area of pixels. The lower the numbers, the less color data is present. Selecting 420, chroma quartered, will further shrink the image size with a quarter of the color data present. The result is a much smaller file. Saving individual images like this can be labor-intensive. For processing entire folders of images, I'd recommend checking out ImageMagick. Visit their download page, select your OS binary, and install. ImageMagick is a command-line tool. It doesn't have a dedicated interface, but it is very simple to use. In a terminal window, write the path of the folder you wish to process. To optimize my images for the web, I resize and compress them, using separate commands to batch resize. This command targets only files with a JPEG extension and resizes them all to a height that I chose, in this case 679 pixels. Specifying just an image height with X will preserve the aspect ratio of the images. The mogrify command will overwrite all files in that folder. To avoid losing any data, back up that folder elsewhere. To also compress the images in that same folder, I like to apply the following settings. All of the compressing options for GIMP that I mentioned earlier are here too. Sampling factor refers to subsampling. Strip removes metadata. Quality is self-explanatory. Interlace line is the same as progressive. I keep text files with these commands on my computer, so I can simply copy-paste them into the terminal when I need them. Just like we can embed hidden information in a JPEG to make it load faster on the web, we can also make small changes to the code on the website itself. Serving images on the web in the right dimensions allows the content to load faster. Say an image that is 3000 pixels wide displays at 800 pixels on the page. The image looks fine, but it is heavy for users to load and it hurts page performance. It is better to resize the image down to 800 pixels or only slightly larger. Another small but necessary change to the code of a website is to add lazy loading to image tags. Images with a lazy loading tag will only load when reached by scrolling down, when they are needed, rather than loading all at once. While the browser loads an image, it does not immediately know the image's dimensions, and because of this, adding lazy loading to tags can cause the layout to shift. To avoid that, specify an image width and height in that same image tag. There are many other things besides optimizing images that can help reduce energy use while keeping the web accessible to all, like using little to no JavaScript, using semantic HTML, removing comment sections and other social sharing features, and reducing CSS. Simple websites keep the web participatory, making it easier for others to view and understand the code and to learn by example. I hope you enjoyed this video. Thank you for watching.